Welcome back. We're going to talk about complex numbers today, and complex numbers are written in the form a plus bi, where a is your real part and b is your imaginary or complex part. Now, complex numbers is based on just two simple facts. Our first one, we're going to build this whole set of numbers just based on these two facts. I equals the square root of -1, and we're going to say and define I squared as being equal to -1. And we're going to learn a whole new set of numbers and do a bunch of manipulation on these two facts. Now we're first going to look at an example, such as the square root of, let's just say, -16. We can say that this is the same as the square root of -1 times 16. When working with these complex numbers, always take care of your imaginary part first. So I'm going to say that the square root of -1 is I, and then that's going to be times the square root of 16. And the square root of 16 is then 4, so I can say that this is 4i. Now, in our imaginary numbers, we could say that the real part is, because this number can be written as 0 plus 4i, the real part is 0, and the imaginary part is 4. You might be asked questions on what is the real part and what is the imaginary part. So extending this, let's look at the square root of -32. We can say that this is the same as I times the square root of 32, and then simplify the square root of 32. 32 is a 16 times a 2, so we're going to say that it is 4i times the square root of 2. In our next example, they're going to ask you to figure out what x and y need to be in order to make this equal. So what you'll do is you'll look at the real part, and here are the two real parts. You can just say that 5 must equal 2x plus 1, and then solve for x. So I would subtract 1 from both sides. 4 equals 2x, and then divide both sides by 2, and x would then equal 2 in order for this to be an equivalency. For the imaginary part, I just look at the imaginary parts of this. And in looking at this, I would say that -3, which is your imaginary part on the left, must equal the imaginary part on the right, which is y minus 4. I'll then add 4 to both sides, and I would say that y equals 1. So in order for this equivalency to hold, x must be 2 and y must be equal to -1. I'm going to look at two examples. We're going to have to know how to add, subtract, multiply, and divide complex numbers. We need to learn how to do all the basic operations. So the example that I chose for you was subtraction. You will take the real parts and manipulate those, and then you'll take the imaginary parts and manipulate those. So this example would look like, I'm going to go ahead and distribute my negative into -5 and then a minus I. This example would then yield 3 minus 5, because I take the real parts and add them to the real parts, would be a -2. And then 2i minus I, and that would be plus 1i, or just plus I. And there's your addition subtraction example. I'm next going to look at the multiplication example. In the multiplication example, I'm going to multiply this entire quantity times this entire quantity. Some of you will call that FOIL. Multiply 3 times 5, that's 15. And then 3 times I, that's plus 3i. 2i times 5 would be plus 10i. And then I'll have 2i times I, which would yield plus 2i squared. You can only add like terms. So I'll have 15 plus 13i. Then the next little part is one that students tend to forget. Remember that I squared is a -1, So I can say plus 2 times a negative 1, and that would yield negative 2, so I can combine that with the 15, and I would get, oh, look there. Conveniently, this is 13 plus 13i. Here's the division example I chose for you. Now, division doesn't really seem like division at all. In fact, all you're doing is really just rationalizing the denominator. And when you rationalize with radicals or square roots, you multiply top and bottom by the conjugate. So that's what I'm going to do. I'm going to multiply top and bottom by the conjugate. And it's going to be messy. So I'll draw a big old line here. I'm going to multiply out this entire quantity times this entire quantity. 3 times 2 is 6, plus 3 times 3i is plus 9i, plus 2 times I, that's going to be 2i, and then plus 3i squared. Multiplying the denominator, I'll get 2 times 2 is 4, plus 6i, minus 6i. Very convenient that that middle term is going to drop. That was the whole purpose. Minus 9i squared. Middle term, like I said, drops out. Simplifying all of this mess, I'll get 6 plus 11i plus 3 times a negative 1. And then I've got 4. And then it's minus 9 times a negative 1. That will yield me 4 plus 9. So I'll get a plus 9 there. And then I get 6 plus negative 3. That's 3 plus 11i. Almost done. All over 13. And splitting this up so that it's in complex number standard form, I have 3 over 13, that's the real part, plus 11 over 13, that's the imaginary part, I. Our next example is manipulating some square roots with negatives. Go ahead and take care of your imaginary part first. So I have I times the square root of 6 times I times the square root of 2. This then becomes I squared times the square root of 12. Inside of 12, I see a perfect number. He's a 4. He can come out of there. When I take him out of there, he'll become a 2. I have the I squared, which becomes a negative 1, so I'll have a 2 times a negative 1. And that 12 was a 4 times a 3. I took the 4 out, so the 3 is still left in there. And I end up with negative 2 times the square root of 3. And I know that's beautiful. In our last example, we're actually going to use our complex numbers in order to find the roots of a quadratic, which is the whole point of manipulating complex numbers in this text anyway. So we learned how to manipulate our complex numbers. We learned the basic operations, add, subtract, multiply, and divide. And now we're going to actually learn how to use the complex numbers to find roots. I have a quadratic here. I would love it if it would factor and give me real answers, but it doesn't. So I'm going to plug it into the quadratic formula, and I need to figure out what A, B, and C are. So I'll do that. A is the coefficient in front of the x term. That would be a 1. B is the coefficient in front of the x term. And C is the coefficient, or is just the number that's by himself. So once again, A is the coefficient in front of the x squared. B is the number that's just in front of the x. So I'm plugging that in to my quadratic equation, and I will get x equals minus b. So that would be negative 6 plus or minus the square root of. I need to take b and square it, so that would be a 36 minus 4 times a, and that would be a 1, times c, and that's a 10, all over 2 times a. So that's 2 times 1, that's just a 2. This would then equal negative 6 plus or minus the square root of this 36 minus 40, so that's a negative 4, all over 2. I then get negative 6 plus or minus 2i all over 2. Simplifying this yields me negative 3 plus or minus I. And there we have it. There's our manipulation of complex numbers.